So we can keep only 2 ice packs. Side and side, we can keep only 2 ice packs. 6 to 8 vials. So both of them at the subcenter level, vaccine carrier and day carrier. So vaccine 16 to 20 vials, cuboid 4 ice packs. Day carrier 6 to 8 vials, 2 ice packs. Next we are coming into the shake test. So which vaccines should never be frozen? Which vaccine it can be frozen? So if you see freeze sensitive vaccines, they get frozen when they are subjected to temperatures less than 0 degrees Celsius. So why we are getting 0 degrees Celsius? It can be due to the cold climate. Like if you go to Ladakh or some other areas where there will be very cold climate, the vaccines may get frozen because you may have incorrect thermostat. In fridge, you have a knob no thermostat. Like this in ILR, we are using an incorrect thermostat adjustment, or the persons who are doing the personnel. So the personnel, they are using wrong procedures. Or we can use, sometimes when we use the ice packs, we are not conditioning the ice packs. Non-conditioned ice packs. So I told you this ice pack, after we put in the deep freezer, we take it, it is frozen. So we have to do something called as conditioning. Conditioning means we should allow some of them to turn into water. So the mild, it should turn into water. That is called conditioning. That is called conditioning. We should allow for thawing. That is called thawing. We should, after taking it from the freezer, we should keep it in the room temperature for 1 or 2 minutes. Then the water in the upside, it will form the fully frozen ice. In the upside alone, small water will form. That thawing, it allows for conditioning of the ice packs. If you are not conditioning it, even the ice pack may lead to sub-zero temperatures. So because of this, the vaccines may be exposed to freezing temperatures. Which are the vaccine which should never be frozen? The vaccines that should never be frozen are mainly the vaccines with the word T. So that is DPT, TT, TD, hepatitis B, pentavalent, even PCV. These vaccines, they should never be frozen. So we'll also see in the next page, they should never be frozen. If they are frozen, they may lose their efficacy. So only if you see these vaccines, they will never come in direct contact with the ice pack. So okay, unknowingly they are being frozen. So what will happen? We have to do a test called shake test. We have to take the control vial and we have to take the test vial. So test vial is already frozen vaccine. So already frozen. So the control vial is the already frozen control. Test vial is the present doubt. What we are having for the doubt in the present. So we are taking the already frozen, which we are taking it as a control. We are taking the present doubt. Both of them we are taking. Then we are shaking and then we are keeping it and allowing it to sediment. So if it forms a cloud like this, it is okay. It can be used. But in term, if you are using a sambar, you all know sambar. The sambar becomes like a rasam with the sediment. The sambar becomes like a rasam with a sediment. Then the shake test has failed. We should not use the vaccine. So if it has become like a cloudy like this, we can use it. We can use this. But if it has become like this, never use it. Don't use because of the sediment. Rasam, the sambar in the hostel has become like a rasam with a sediment. All the things, the grams, green grams or all what Bengal grams, it has sedimented. Then we should never use that vaccine. So shake test done to check whether vaccines have been exposed to freezing temperature or not. A vial of frozen vaccine after it has been thawed no longer has the appearance of the cloudy liquid. It tends to form flakes that settle at the bottom. You have to compare the rate of sedimentation in both the test vial as well as the control vial. The rate of sedimentation is same or it is faster in the test vial, then the vaccine is damaged. We should not use it, we have to throw it. So another question is, shake test is not applicable for which vaccine? It is not applicable for IPV. Why? It does not have aluminum conjugate. So aluminum adjuvant. Because in inactivated polio vaccine, there is no aluminum adjuvant. So we cannot do shake test on it. In order to do shake test, what is the basic criteria is we need to have some adjuvant. That is this aluminum adjuvant. So shake test is not applicable for IPV. So next we are going into ILR, ice lined refrigerator. So you can see this fridge. It is not in our home fridge where we open like this, but it is like in here, like our own ice cream or other ice cream fridge, because it can hold the air inside for longer if it is like a top opening instead of the front opening. So it maintains the cabinet temperature between 2 to 8 because it is only a refrigerator. Only the deep freezer maintains temperature of -20. So top opening type. Inside of the ILR we have upper part as well as the lower part. Upper part, lower part. So if you see lower part, it is cooler. So mainly we can keep only the freeze sensitive vaccines. What are the vaccines that can be stored even at -20? Mainly OPV, measles, BCG, and sometimes JE above that. This we can store in the bottom because OPV, it can sustain minus temperatures, -20. So OPV, measles, BCG and JE. Then in the upper part, we mainly keep all the freeze sensitive vaccines, DPT, TT, hepatitis B, IPV, pentavalent, diluents. These are all mainly sensitive, freeze sensitive vaccines. So we are keeping it in the upper part of the basket. So these vaccines, we should never keep in floor or in direct wall of contact because they are sensitive to freezing. So in case we do not have any baskets, so inside this they will have some baskets. So here we may have some baskets like this. In this baskets only we are going to keep. We are not having baskets. What we should do is we have to take 2 ice pack. So there is baskets are not available. In case the baskets are not available, we are having a chance like we have to keep it in the floor only. So at that time what you should do is you have to take 2 ice packs. And you have to keep the 2 ice packs which are empty, and above that you can keep the vaccine vials. The vaccine vials should always be kept in a polythene bag. The vaccine vials should always be kept in a polythene bag. So never keep in floor or direct wall contact. Keep 2 empty ice pack if no basket. About the ice line refrigerator. Next we are going into the universal immunization program or the national immunization schedule. So this detailed schedule or the same schedule with more clarity, it is in your page 36 of your vital capsules. In page 36 of the vital capsules, you have the bigger table with more clarity. So National Immunization Schedule or Universal Immunization Program, when it was launched, it is called as the Expanded Program on Immunization. Initially, they had vaccines only against 6 common preventable childhood diseases. Our DPT, diphtheria, pertussis, tetanus. Then they added OPV, then BCG for TB, and then measles. Only initially against the 6 things we had. Then later UNICEF gave support to this program. Then India launched its EPI, Expanded Program of Immunization, in 1978. It turned into universal immunization program where we added vaccines against tetanus for women. Then slowly now we have our whole national immunization schedule. Another schedule which is followed in private is Indian Academy of Pediatrics. So this government is free of cost. In India, government free of cost. So all of you will get this vaccines free of cost. But the private, we have additional vaccines like for vaccines for typhoid, vaccines for maybe cholera, or they also have vaccines for chicken pox. But it will cost a dose or one needle for chicken pox or varicella. It can come around 3,000 rupees. But in government, everything is free of cost. So what are the vaccines? At birth, we are giving BCG, OPV 0 dose, hepatitis B birth dose. Then at 6 weeks, 10 weeks, and 14 weeks, we are having 3 doses of OPV. OPV is just 2 drops. Rotavirus 1, 2, and 3, it is 5 drops. Pentavalent, it is a combination of 5. Diphtheria, pertussis, tetanus, hepatitis B, Haemophilus influenza type B. Then at 6 weeks and 14 weeks, we have fractional IPV. What is this fractional IPV? So in the world level, IPV is used in the intramuscular. It will come as 0.5 ml. But India, in order to reduce the cost or expenditure, we are using 0.1 ml, that is intradermal. So only it is called as the fractional IPV. Then PCV, pneumococcal conjugate vaccine to prevent against pneumonia. Recently, they introduced the fractional IPV third dose. It may not be seen in the old books. It is the recent in the fractional IPV third dose at 9th month. At 9th month, we are giving the MR first dose measles with rubella. Then we are giving Japanese encephalitis first dose. Asterisk is mainly for endemic districts. In districts mainly with the mountain related districts where Japanese encephalitis or brain fever is common. Then we are giving a booster for PCV. Then at 1.5 years of age, we are giving the first booster for DPT, one booster for OPV, second booster for MR, measles with rubella, and second dose of JE, second dose of MR, and second dose of JE. So boosters for DPT and OPV, and second dose of MR and JE. Then when the child, it has to come back only at 5 to 16 years, second booster for DPT. After 7 years, we will not give pertussis. So pertussis is not recommended because it may cause side effects or adverse events. So after 7 years, pertussis component is not recommended, it is removed. So at 10 years, we are giving TD, tetanus with a diphtheria. 16 years, we are giving TD. What is this D means? Adult diphtheria. Reduced dose. Child will give high dose of diphtheria. In adult, we are giving reduced dose of diphtheria. Pregnant mothers, 2 doses of TD. What is the minimum gap between the 2 doses? It is 4 weeks. In case if the pregnancy occurs, second pregnancy occurs within 3 years, then we can give only 1 dose in the subsequent pregnancy. That is more than enough. So next we are going into AEFI, adverse events following the immunization. It is nothing but any untoward event occurring, but not necessarily causal. So even if the child dies because of some other disease also, if it is coming to the vaccination center, after putting the vaccine, it dies, it will be considered as a AEFI. Then we have to classify it. We have to classify it as a true adverse event or a coincidental event. If you see the true adverse events, there are 4 types. Vaccine product related, vaccine quality defect related, then immunization error related, and immunization anxiety related. What is vaccine product related? So some adverse events are inherent to the vaccine. For example, after putting the DPT vaccine, diphtheria, pertussis, and tetanus vaccine, there can be extensive swelling of the limbs. It is inherent to the product. It is okay. Then what is vaccine quality related is while preparing the polio vaccine, the polio viruses may be inactivated, not properly inactivated. So it may cause vaccine associated paralytic poliomyelitis because of the vaccine quality is not correct. What is immunization error? Cold chain failure. We are not maintaining the proper cold chain. So the vaccine that has lost its potency, we are giving, then the vaccine may not be effective. Sometimes it may cause some adverse events. It may cause some toxic shock. The vaccine is not stored properly. It may get contaminated and it may cause some adverse effects to the child. It is due to the inappropriate handling. Or instead of putting a vaccine in intradermal, we are putting it as intramuscular. So inappropriate handling or administration. So next one is immunization anxiety related. So after putting the vaccine, certainly vasovagal syncope. The child suddenly gets a syncope. See, it is not due to our fault, but it has happened. It is due to the shock. The child may develop a shock, vasovagal syncope. The last is the coincidental events, which is not related. So some child may have some other disease. Because of the disease, the child may die. It may not be related to vaccination. The child would have had some cancer. That is coincidental events. So this picture is just about the milestone AEFI program, how the program evolved. That's just for factual, nothing much into it. Next is hold over time. You can see a thermometer here. Okay. So what is this hold over time is normally what we have to do. See the freeze vaccines, that is OPV, it has to be stored at minus 20 degree. So the vaccines which can be resistant to freeze. Then other vaccines, for example, we can take hepatitis B. It has to be stored at 2 to 8 degrees Celsius. So every vaccine has a storage temperature. Diluents also stored at 2 to 8 degrees Celsius. Now the current is gone. Okay, some of the PHCs they may not have a electric current generator may not be there. At that time, till what time the refrigerator can hold the temperature properly and it can maintain its temperature. That is called as the hold over time. So you have to maintain the temperature between 2 to 8. Okay. So the hold over time is the time taken by the equipment to increase the inside cabinet temperature from temperature at power cut to maximum limit of the recommended range in case of the power failure. Now at maybe 11:15 there is a power failure. Now the ILR temperature is at 4 degrees. What is the maximum temperature allowed is 8 degrees. Then the time taken to reach 8 degrees is called as the holdover time. So usually the ILR, the Iceland refrigerator we saw, no, which is like a opening, top opening. It can maintain the, it is minus 20. So OPV is stored at minus 20. So the ILR, it can maintain the temperature of for 24 hours if we give current for 8 hours. So with 8 hours continuous power supply, it can maintain the temperature for 24 hours at 2 to 8. This is the capacity of the ILR. So this holdover time depends on several factors like what is the temperature outside, how many times we are opening and closing, how many vaccines we are keeping, then the ice packs. So if you see the ILR surrounding all the surroundings, we will have an ice pack lining. What is the condition, whether it is in top state or not. So these are the conditions which affect the holdover time. So you can write here what are the freeze sensitive vaccines. So all the complete list. So what are the freeze sensitive vaccines which should never be frozen? All the vaccines with the word T. You remember T, T, T. DPT, TD, pentavalent, hepatitis B, Haemophilus influenza type B. Then we have inactivated polio vaccine, PCV, rotavirus, influenza. All these vaccines, they should never be frozen. So you can remember the TTT is important. These vaccines, they should never be frozen. These are all freeze sensitive vaccines. So they will never be kept in the bottom. They will be kept in the upper part. So next we are coming into diluents. See here also I am telling again, some vaccines they are available as even freeze sensitive vaccines like powder form. Powder form vaccines, it is not a problem to keep it in contact with the frozen temperatures, only in liquid forms. So you should also remember that. You should not always see blindly. Rota means in rota there are two things. One is liquid vaccine and another is powder form. So this liquid vaccine may be only freeze sensitive. This powder form, it may not be freeze sensitive. It may be even freeze resistant. Okay, remember that. Then we are going to diluents. See, some vaccines are in powder form. We cannot put the powder, child open. You cannot put the powder. We have to add it with a diluent and make it as an injection and we have to inject. So for every vaccine, we have to add a diluent. So the diluents used for reconstitution of vaccines. Distilled water for measles vaccine. Distilled water. Normal saline for BCG. Phosphate buffer for JE. This yellow fever we are not using in India, so it is not much important. 0.9% sodium chloride for yellow fever. See, yellow fever, it is not present in India, but it is present in America, South America, and Africa. So it can come to India maybe through the mosquitoes. So only we have to be ready. Not present in India presently. So this yellow fever. Then, so for emergency only we are storing the vaccines. So these vaccines may not be available everywhere. It may be available only in the important cities, mainly where they are giving the vaccination. So it may not be available everywhere in India. So diluents we have to store at 2 to 8 degrees Celsius, and the diluent should not come in contact with ice packs because ice packs are frozen. It may subject the diluents to minus degrees Celsius. Only use the diluents supplied by the manufacturer. In case if we are storing the diluents in the room or outside or maybe in the room temperature outside the cold chain, then you have to cool them for 24 hours before use to ensure 2 to 8 degrees Celsius. Otherwise, what can happen? It can lead to thermal shock. Just you are taking it from the room temperature, from your cupboard. The vaccine is in 2 to 8. If you are mixing it both, then what will happen? It may lead to thermal shock. Like we can take for example like your drinks, some alcohol you are drinking. What they are telling is the water you are going to add to the alcohol should be at the same temperature of the alcohol. So both of them they should be stored like at 2 to 8 like this. You remember. Otherwise, what it can do? It can lead to thermal shock, death of some or all the live organisms in the vaccine. Next is which vaccines have dark glass vial, amber color. Do you remember the amber color vial? So you can see the amber color is, so this vial you can see it is somewhat light, dark black color. Example, it is not the exact, but like an example, dark color vial. So this is the amber color vial. For what are the vaccines? We use this light sensitive dark glass vials. We use it for BCG, measles, and MR. So we use dark glass vials because they are light sensitive. Okay, guys. Next, we go into biostatistics. So classification of data. How can we classify the data? They can be classified into quantitative, qualitative. So qualitative means only names. Like what is your gender? I am male. C is female. Only names. What type of anemia you have? I am having megaloblastic anemia. She is having sideroblastic anemia. So only names. I am vaccinated. She is not vaccinated. That is qualitative. So what is quantitative? Quantitative means numbers. My height is 173 centimeter. Samantha standing near me. Her height is 165 centimeter. Rajinikanth is standing near me. Sir's height is 180 centimeter. So that is quantitative numbers. They will have units. They will have some units and they can be measured with a scale. Names means no units and they cannot be measured with a scale. They can only be counted. So quantitative numbers, they can be discrete or continuous. Continuous means it may have decimal points. Like height. If you see, although I told the height is 167, my height is 167.32. So it is continuous. Height, weight, everything is continuous. It is continuous. Even HbA1c, continuous. 68.8 kg. Discrete means whole numbers. So discrete means whole numbers. You can strike it out because it may confuse you. You can just put discrete means whole numbers like your heart rate, pulse rate, RBC count, WBC count. Because either heart rate, lub, tub. It cannot be lub, tub, half. Either it beats for her or does not beat for her. That's all. Alive, death. It is not halfway. So that is discrete whole numbers, continuous in decimal points. So data, qualitative or quantitative, quantitative numerical using a measurement scale, units, it can be continuous or discrete, qualitative, categorical, no units, like just only names. These names can also be with order or without order. So we have different types of data. How are we going to measure this data with various scales? We have 4 scales. You know T Kada Nair in Kerala, nominal, ordinal, interval, ratio, T Kada Nair. Nominal means only names without any order, like male, female. See, female is not greater than male, male is not greater than female. So there is no relationship like they are more than this, they are more than this. So there is no order. But if you see if there is inherent order, the scale we use is ordinal scale. Like we can tell anemia as mild, moderate, severe. Or we can tell Kupuswamy socioeconomic status scale, upper class, middle class, lower class. So names with some inherent order. Then we have interval and ratio. So interval scale means they are also numbers. Ratio is also for numbers. Nominal and ordinal, this is for names. Interval and ratio scale is for numbers. The numbers where even 0 has a meaning is interval scale. See, the temperature of this room is 0 degrees Celsius. That does not mean there is no temperature. 0 degrees Celsius means cool temperature. So even 0 has a meaning. There is no absolute 0. Even 0 has a meaning. That is the interval scale. Can I write it here? Even 0 has a meaning. Even if 0 has a meaning, that is interval scale. In ratio scale means 0 means 0. In ratio scale, 0 means 0. Like what we can tell, whom we can take. We finished Nayanthara Trisha, we can take maybe Deepika Padukone. Deepika Padukone standing near me has 0 height, 0 weight. Amir Khan standing near me has 0 height, 0 weight. That means there is no Amir Khan near me. So that is a ratio scale, but the temperature is 0 degree means it is a cooling temperature. If 0 has a meaning, then it is an interval scale. 0 means absolute, 0 means it is a ratio scale. Out of the 4 scales, which is the best, Kanna best? The best scale out of the 4 is the ratio scale. Which is the worst, Kanna worst is nominal scale. Why ratio scale is best is because division, multiplications are possible in ratio scales. In ratio scales, division and multiplication are possible. So division and multiplication possible in ratio, but not in interval scale. Next question you get is, what is the Apgar score? You're having no Apgar score. Likert scale. Likert scale is nothing but you see in Amazon or how are you satisfied with our customer service? Rate our service in terms of 1, 2, 3, 4, 5. So rate our customer rating. So I will give you 5. Uber. So that is nothing but it is the Likert scale. So we have some numbers. They are in some order and we have to choose. So most of the scales used in psychiatry. For depression, we use a scale. For daily, how do you feel? How is your mood? Do you feel like killing yourself? Like this. For depression, we use a scale. That is also an ordinal scale. Like they are in an order. So most of the scales used in psychiatry are ordinal scales. They had to give up a score, even Apgar score. How is the child, what is the color of the child, reflex or the response of the child, grimace, cry, 0, 1, 2. For each 5 categories, 0 plus 1 plus 1 plus 1. Totally it is 5. The child has depression or not. The child has respiratory depression. The child has no respiratory depression. For Apgar score, we use no. So all of these are ordinal scales. So nominal scale names, for example, anemia can also come as a nominal scale. Here it is megaloblastic or iron deficiency or sideroblastic. If you are telling the types of anemia with names, it can be only a nominal scale. Ordinal means we are having Kupusamy scale, upper class, middle class, lower class. Interval scale, temperature in Celsius. Then we are having ratio scale, weight in kilograms. Next, we are going into the bar graph. So what are the diagrams we can use for various types of data? It is in page 41 of your vital capsules. You can make a note here. It is in page 41 of your vital capsules. So bar diagram we can use for what data? Quantitative or qualitative? See, bar diagram we can use only for qualitative data. So qualitative data, we can use bar diagram. So qualitative data means what is the number of boys and girls in your school? Number of boys and girls in your school you can tell. So okay, there are 20 boys, 40 girls. It is a qualitative data. So we are using bar diagram. For qualitative data, what are the other diagrams we can use? Pie chart. So this is a pie chart. So we can use pie chart. So next we can use a spot map. In the map, how does the cholera spread? That is the spot map. So these are the places where there is cholera. These are the houses where there is cholera. That is a spot map. This is the pie chart. Pictogram means like pictures. So for one doctor, under one doctor, how many nurses are working? So in India, under one doctor, we have 4 nurses. But in America, under one doctor, we have 2 nurses. So how much doctors per population? We can do it in the terms of the pictures. That is pictogram. Next is Venn diagram. So what is Venn diagram is? See, these many people have diabetes and these many people have hypertension. Diabetes, hypertension. So if you see the people in the center, they have both diabetes and hypertension. This is Venn diagram. So bar chart, it is a chart with rectangular bars. You have to know important point in the bar chart is there is gap between the bars. So there is a gap between the bars. Because these are only qualitative data. They are only names. Illiterate how much, how many are primary education, how many are graduate. So it is only a qualitative data. There will be a gap between the bars for the qualitative data. Next we are coming into histogram. See, there is no gap. You can see here there is no gap. They are closed. So since here there is no gap, it is called as the histogram. In histogram, there will be no gap between the bars. There will be no gap between the bars. In the bar chart, there will be presence of gap. In histogram, no gap. So it is used for representing what data? Quantitative data. So how will you are getting this bars without any gap? Because it is used for quantitative, especially continuous data. For example, the height. We are taking the height of 100 students in the class. So 20 students are having height between 175 to 200. 20 students are having height between 200 to 225. Another 20 students 225 to 250. Similarly, here they are taking the serum cholesterol levels. How many students are having? See, 3 students, 3, 2. Here one student is having cholesterol level between 275 to 300. Three students are having cholesterol level between 175 to 200. So since we are taking a continuous data like a cholesterol, the graph is coming without any gap between the bars. So this is called as the histogram. So we have something called as the class intervals. So in the bar chart, there is no class intervals, but in the histogram, there is class intervals, because in histogram, we are using a quantitative data with class intervals. Then if you take the midpoint, so what we are doing, we are taking the midpoint of all the bars and we are joining the midpoint. If we take the midpoint of all the bars in the histogram and join, it is called as the frequency polygon. So this is called as the frequency polygon. So when the number of observations is large, this polygon loses the angulation and it becomes a curve. That time it is called as the frequency curve. So it loses the angulation and it becomes a curve. It is called as the frequency curve. So frequency polygon. So it is like this. So when the number of observations, we are doing it for so many number of people in the whole world, it loses the angulation and becomes like a curve, frequency curve. The most famous curve is the bell-shaped normal distribution curve. So you should know the difference between bar chart as well as the histogram. So next we are going into the another thing for quantitative data, that is box and whisker plot. So we'll have a break at 12 o'clock. So the break has been extended. Okay. Next is box and whisker plot. So what you see in a box and whisker plot, the basic idea is, now we are having how many friends? 4 friends. Each friend should sleep in a different room. They don't want to be disturbed. What we can do? So that is the house. We have to divide the house into 4 rooms. How can we divide the house into 4 rooms? We have to build 3 walls. 1, 2, and 3. So we are building 3 walls inside the house. So it becomes first, second, third, 4. So by using 3 divisions, we are dividing the house into 4 parts. This is the basis of the box and whisker plot. In the center we are joining, it becomes a box. If we join in the center, it becomes a box. So totally we are having 4 parts. We are using 3 divisions. These 3 divisions are called quartile 1, quartile 2, and quartile 3. Totally we are having how many parts? 4 parts using the 3 divisions. So here, this is the box. This is the box. Then which is called as the whisker. This is the whisker. So only it is called as the box and the whisker plot. Box as well as the whisker plot. In a box and whisker plot, there are 4 parts divided by 3 divisions. So whisker represents the whole range of the data from the minimum to the maximum. The box represents the interquartile range. This is called as the interquartile range. This is called as the interquartile range. So what is this interquartile range? IQR is equal to Q3 minus Q1. So see in this diagram, what is Q3? 12. What is Q1? It is 9. So 12 minus 9 is 3. That is the interquartile range here. So what is the importance of the interquartile range? Since we are dividing it into 4 parts using 3 divisions, so the first 25% of the values are here. Next to 25. Next to 25. Next to 25. Okay, here if we see, Q2 is the median. So Q2 is the median. So median is the Q2. Now, what is the number of values covered by Q1 to Q3? So first 25, last 25. So next 25. So the middle 50% come inside the interquartile range. So the interquartile range includes the middle 50%, that is from 25% to the 75% of the values. So in a small glance, you can tell in the class what is the minimum mark. The minimum mark scored by the class is 0. The maximum mark scored by the class is 18. So what is the interquartile range? 9 to 12. IQR is equal to Q3 minus Q1. So it is 3. So what are the other tools for expressing this quantitative data is one, histogram, frequency polygon, frequency curve, box and whisker plot. Other than this, we have Auju, scatter plot, stem and leaf plot. Another name for Auju is, it is similar to the frequency curve. It is called as the cumulative frequency curve. So we already saw histogram, frequency polygon. Now we saw box and whisker plot. Other things are Auju, scatter plot and stem and leaf plot. So next is the stem and leaf plot. It is like a tree. So we have a tree. So we have the tree. From the trees, we are having the leaves. So the leaves are coming. So this is the tens place. This is the ones place. So how can we read this data? The first line can be read as 62, 66, 68, 62, 66, 68. Second line 70, 71, 72. Last line 100, 90, 95, 97. So this is a stem and leaf plot for summarizing quantitative data. You have stem is in the vertical direction on the left side, leaf is on the right side, read horizontally. The tens place is in stems, the last digit or ones place in leaf. At a glance, we can have an idea about the shape of the distribution. What question they can ask is, they can give you this diagram and ask you to find mean. So arithmetic mean means you have to add everything and divide by n. So you have to add everything and see how many numbers are there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16, 17, 18, 19, 20. So you have to add everything, and then if you divide by n, you will get the value. So this is the use of the stem and leaf plot. Next, we are going into the scatter plot. So what is scatter plot is, we can take 5 actors like Kamal Hassan, Rajinikanth, Shah Rukh Khan, Amir Khan, Amitabh Bachchan. We are taking the height of the actors in one side and weight of the actors in one side. So first for Kamal Hassan, it may come like this. Height 170, weight 60. Amitabh Bachchan, Shah Rukh Khan. So it will come. So we get so many points here. If you see in this diagram, similarly, they have drawn a graph between age in months and the body weight of the children. So age of the child in months and body weight of the child. If you see, they have taken around 20 to 25 children. If you see, as the age is increasing, the weight of the child is increasing. So we are getting a plot like this. So this is called as the scatter plot. Another name for the scatter plot is, it is also called as the correlation diagram. So what is the use of this scatter plot? It is used for correlating two quantitative variables by plotting one on x-axis and the other on y-axis. See, this association is not necessarily causal, because we are doing it only like a cross-sectional study. At the same time, we are taking all the actors and we are plotting their height and weight. It is only like a cross-sectional study. So we cannot tell which came first or which came second. So it tells some association, which is not necessarily causal. So we can have the correlation diagram, either it can be positive. So positive means the graph will grow up, height and weight we can take. Negative means the graph will come down, like physical activity in minutes and your cholesterol levels, LDL. If you do more physical activity, your LDL level will decrease. That is a negative. No correlation means graph will be like this. Here, for no correlation, you have to take biryani in grams and cancer. So biryani in grams and cancer. So there is no relationship between the amount of biryani you take in grams and then the cancer. That is no correlation. So positive, negative and no correlation. So for correlation, we use the word or the letter called R. So this symbol denotes the correlation coefficient, the linear relationship between these two variables. So correlation. Another question they can ask is, scatter plot is used for drawing the relationship between two quantitative variables, and usually they are two continuous quantitative variables. Here height and weight is there. So all other graphs we used only one variable, like we draw either the height alone or weight alone. Here we are drawing the relationship between two variables, especially quantitative variables. In that also, especially we use it for continuous quantitative variables. So after we draw the graph, we can get the answer between -1 to +1 for correlation coefficient. So -1 means perfect negative correlation, +1 is perfect positive correlation, 0 means no correlation. So this is -1, this is +1, and this is no correlation. Next, we are going to the normal distribution curve or the standard distribution curve. So if you take the height of all the people in the world and you draw a diagram, it will form a normal bell-shaped curve. This is called as the bell-shaped curve because the bell looks like this, no? So it is called as the bell-shaped curve or a Gaussian distribution curve. It is a symmetrical curve. If you see, the tails do not touch the baseline. It keeps on going. What is the total area under the curve? So if you see, the total area under the curve is 1. The total area under the curve is 1. So in this curve, if you see, the mean, median and mode are in the center. It is 0. So mean, median and mode are in the center and it is taken as 0. So what is the standard deviation of this curve? Standard deviation is taken as 1. So what is called as variance? Variance is nothing but square of standard deviation. That is also called as 1. Then we have to see the areas between. So you can see this curve, there is a totally the area is 1. So now if you see what is the area between -1 and +1 standard deviation. So the area between -1 to +1 standard deviation here, it is 68.3 percentage. 68.3 percentage. Now what is the area between -2 to +2 standard deviation? So area between -2 to +2 standard deviation is the area between -2 to +2. This area is 95.5. 95.5. So mean plus or minus 2 standard deviation. Mean plus or minus 1 standard deviation is 68.3. So I am the mean, 1 arm distance, 1 arm distance. It is 68.3. Now 1 arm, another 1 arm. So 2 arm distance on both sides. It is 95.5. It is 3 arm distance. So 1 arm, 2 arm, 3 arm. So 3 arm distance on both sides. So we are having the 3 arm distance on both sides. So if you are having the 3 arm distance on both sides, then it is 99.7. So 3 arm distance on both sides, it is 99.7. So based on this, what questions you can have? See, for 2 standard deviation, it covers how much? 95.5. Then how much will be above +2 standard deviation and how much will be below the -2 standard deviation? So mean plus or minus 2 standard deviation is 95.5. So 100 minus 95.5 is 4.5 percentage. So hence 2.25 percentage will be above the -2 standard deviation and 2.25 percentage will be below the -2 standard deviation. So another question as this, 95.5 is mean plus or minus 2 standard deviation. What is the exact thing for 95 percentages? Mean plus or minus 1.96 standard deviation. It is the most commonly used confidence limit. This is the most commonly used confidence limit is the mean one plus or minus 1.96 standard deviation. Okay, guys, you have got the idea now. We'll go into the next measures of central tendency. In another 13 minutes, we'll have a break. Okay. Next, we'll have the measures of central tendency. So there are three measures of central tendency: mean, median, and mode. Central means center. How can we find center? In the hostel, we are there. In the hostel, each one is eating. I am eating 5 idli. You are eating 3 idli, 4 idli. How the mess master will know? He will cook on an average 3 idli. 100 students, 100 threes are 300. So to find the center, that is called mean, median, and mode. So mean means always the formula for mean. It is summation of x by n. Although there are many means, the most commonly used mean we use is arithmetic mean. It is obtained by adding all the observations and dividing by the total number of observations. But in case of the observations which are less than 30, the mean may not be the best measure. So mean is the best measure only when there are more than 30 observations. In case of outliers as well as less than 30 observations, that is n is less than 30, which is the best measure is median. The median is the middle value. We are having three values like three children, 1 kg, 3 kg, 5 kg. You have to put them in an ascending order. The center value is called as the median. So median is the central value. How will you calculate mean? 1 plus 3 plus 5. Totally it is 1, 2, 3. So 9 by 3. So mean is 3. So mean is adding everything and giving us a single number. Median is choosing the centermost after putting them in the ascending order. So median is the better indicator if the set of the scores has an outlier or it has some skewness. Skewness means my face is symmetrical. This is normal. This is skewness. Skewness. This is skewness. Okay, next mode. Mode means the most repeated value. Here nothing is repeated. But for example, we can take the three children weight 1, 3, 3, 4, 5 kg or 5 children weight. Here the most repeated value, if you see 3 is repeated 2 times. So mode is here is 3. But if you see in this sum, nothing is repeated. So there is no mode for this sum. There is no mode here. So mode is the most frequently occurring value. Then there is something called bimodal distribution. Bimodal means a distribution which has two peaks. A distribution which has two peaks. So this is a bimodal distribution. For bimodal distribution, we have a formula for mode. So the formula is mode is equal to 3 median minus 2 mean. Mode is equal to 3 median minus 2 mean. Okay. Next, we are going into measures of dispersion. Till now, we saw the center. Now, we are going to see how much we are away from the center. Measures of dispersion. So, measures of dispersion, how much you are away from the center. That is called as the measure of dispersion. So, the main measures of dispersion we are using for our exams is mainly range, standard deviation. These are the main thing. Although we have range, mean deviation, standard deviation, quartile deviation, the main thing is range and standard deviation. So what is range? For example, if there are 5 students in a class and we are having the height of the students 170, 180, 185, 190, 195. Range means we have to take the smallest value as well as the largest value. So we have to subtract the maximum minus the minimum. So 195 minus 170, that is 25. This is called as the range. Then standard deviation, we have a formula. So it is absolute measure of dispersion. The formula for standard deviation is summation of adding everything x minus x bar the whole square divided by n. So what is the meaning here is, here x means mean, x bar means the each value, n means the total number of observation. Either you can use this formula or this formula. See, don't worry about which is x bar. So the first one coming is mean. The next one coming is given value. So both the formulas will be used interchangeably in the books. Either you can use this or that, but don't use both. So because you will get confused. So the idea is mean. So square root of summation of x minus x bar the whole square divided by n. The first one is mean. The next one is the given value. So I will prefer you to use this for all purposes and you can avoid this. Okay. Then there is something in this formula. So if the total number of observation is greater than 30, you will use this formula. But if the number of observation is less than 30, you have to use n minus 1. If you use this formula, if n is more than or equal to 30. In case if n is less than 30, we have to use it as n minus 1. In the denominator, we have to use it as n minus 1. If n is less than 30, if it is not, you can use n. So that you have to remember. Then variance is the square of standard deviation. There is something called variance. Variance is nothing but the square of standard deviation. This is the absolute measure of dispersion. Then we also have relative measures of dispersion. The most often used relative measure of dispersion is coefficient of variation. The formula is standard deviation by mean into 100. It is a relative measure of dispersion. So coefficient of variation, it is a relative measure of dispersion. Formula is standard deviation by mean into 100. Okay. Next we are going into skewness. So you know a normal curve. The skewness means it tells about the abnormal curve. So see here, here the tail is long towards the right. So tail towards the right. If the tail is long towards the right, it is called a right or positively skewed. If it is right or positively skewed, then how it will be? Always mean. We eat mean with the right hand, you can remember. So mean will be the largest. Mean is greater than, median is greater than mode. Next, if the tail is long towards the left hand side, tail is long towards the left hand side, then it is a negatively skewed or left skewed. So for left or negatively skewed curve, which is the largest of the values, always it will be mode will be the largest. So if you are in a bad mood, we use the left hand. We use the left hand to slap, we use the left hand to clean, like bad mood. So mode is the largest in the left skewed curve. Mean is the largest in the right skewed curve. Okay, see it goes from 0 to 100, 0 to 100. Always median will be in the middle. Always remember median will be in the middle. So you can see here, mean is greater than, median is greater than mode. But if you see here, mode is greater than, median is greater than mean. So left or negatively skewed, it is right or positively skewed. So skewness tells you the amount and direction of the horizontal symmetry. Like similar to skewness, we have something called kurtosis. Kurtosis means height, how much height you are. It tells the sharp of the peak of the curve. See, in a normal curve, there should be no skewness. Skewness should be 0 and kurtosis should be 3. You can remember like this. Keep your hand. Skewness is 0. Kurtosis is 3. Okay, you can keep your hand like this and you can feel. So skewness should be 0. Kurtosis should be 3 in a normally distributed curve. So negative means left skewed. When you are looking at the exam question paper in front of you in the computer during your exam, if it is the tail is long towards the left or negatively skewed. Positive means right skewed. Mode will always be at the peak, median will be in the middle, and mean will always be at the tail. Next is asymmetrical distribution. So there are many types of asymmetrical distribution. First distribution we saw was skewed. Next, what is given in the below diagram is Poisson. This is called as the Poisson distribution. So this diagram is what distribution? It is a Poisson distribution. So kurtosis means the height. Kurtosis is height. What is the asymmetry in the height? Left hand side, right hand side of the face. Horizontal asymmetry is skewness. What is the difference in the height? That is kurtosis. So this is a normal curve. Okay. So this is the very high curve. This is a very low curve. So this difference in the height is called as the kurtosis. Okay, this is skewed distribution, Poisson distribution. Next, the other types of distributions are J-shaped and multimodal. These are all examples of the asymmetrical distribution. So what is given in the picture is the Poisson distribution. So Poisson distribution is usually skewed towards the right hand side. It is a discrete probability distribution. Discrete means a event which has either yes or no type of event, like it is a whole number. It is a whole number. So what is the number of RTA? So rather than this yes or no, we can tell it is a whole number event. Like what is the number of RTA? We cannot tell 2.5 or 3.5. We can tell it only whole numbers. Like in 2024, there were 25 RTAs in the national highway in Mumbai. So it is usually a rare event. So it is usually a rare event. It is usually given for rare event because accidents in a road is not like daily 500, 200 or 100 are not happening. Daily in a road maybe rarely one event. In a month in a single road maybe 20 or 30. It is a rare event. It gives the probability of the discrete rare outcome. It is the probability of the given number of events in a fixed interval of time in a large population. What is the number of RTA during 2025 in Mumbai in a single road? In a single road, daily lakhs and lakhs of people may go, but only 2 or 3 accidents may occur. That is called as the Poisson's distribution, distribution of a discrete rare outcome. Okay, students, maybe we'll stop with this and we will have a 10-minute break. You can come back at 12:10. Then around 1 o'clock, we may go for lunch. Okay, 12:10, you can come back. There's a 10-minute break.